Good afternoon. How's everyone doing today? Are you excited about the event tonight? Finally, we have some party after all this heavy week, right? Okay. How many of you have used PostgreSQL? Okay. MySQL? How many of you have used, or at least tried to use, Azure Database for PostgreSQL? How about Azure Database for MySQL? Cool, so we have a few users of Azure DB for open source database. Great, so welcome to the session. My name is Harini Gupta. I'm a senior program manager in the engineering group that builds Azure Database for PostgreSQL and MySQL services. Specifically, my role on the team is focusing on the success of the customers who are onboarding to the Azure open source database platform. Joining me here today are John Eve, or JY, who's also a program manager on the customer success team, Prabhat, who owns the engineering team for Azure Database for PostgreSQL. And we have a very special guest today, Dave from Adobe, who's a solution architect. And he's going to discuss with us in details how Adobe leveraged Azure Database for PostgreSQL. So having worked with several customers like yourselves, both in large enterprises as well as small and medium businesses, across different industries such as retail, healthcare, education, and other professional services, whether they are trying to migrate their on-premise workloads to Azure, or migrating their workloads from competitive platforms such as AWS to Azure, or even building a brand new cloud application, we've seen them recurrently asking some of the key important questions based on our engagements with them. First being, how do I migrate my Postgres database to Azure? How can I tune my Azure MySQL instance? Or how do I optimize my application to work with Azure PostgreSQL? Do these questions resonate with you? I'm sure you're asking yourselves these. So let us share with you how these customers have answered those questions. And we hope you'll be able to take home some of these recommendations around migration, Azure deployment and maintenance, and customizations to get the best possible experience with Azure Database for PostgreSQL or Azure Database for MySQL. Now, the next set of slides are actually, we're going to walk you through each of these topics that I just mentioned: migration, Azure deployment and maintenance, and customizations. And we tell you the customer story and how they actually overcame some of the challenges that they faced. So let's talk about migration. So the customer here is one of our key retail customers in Azure, Staples. And they have an entire e-commerce web application for vendor and order management. So running on Apache web servers, Tomcat on application layer, Redis and Postgres on the data layer. The data workload size is about 250 to 600 gigabytes. They also have, from a business standpoint, they have a very strict requirement to meet their end users, an SLA of less than 6 hours, less than or equal to 6 hours application downtime. Now, do you guys have such stringent SLAs for yours? I see a laughter here. So let's talk about what's their journey and how they went through migrating their on-premise workload from Postgres to Azure Postgres service. First of all, they were on a very, very old version of Postgres, which is 9.2, and then some of them were also 9.3. And they had to upgrade their Postgres to an Azure-supported version, which is the 9.6 version. During that time, since they have a very old schema, which many of you are familiar with, you have to check your schema to make sure the unsupported data types and null values are also taken care of, so it makes it a much smoother migration. And then one of the ways that they migrated using was the backup and restore process, which is by using the native tools of Postgres, PG, dump, and restore. Some of the switches are recommended that we use for backup is for the -FC flag, which actually parallelizes your process. So it speeds up your backup. From a restoration standpoint, what they did was they restored it in using, some of the recommended switches. And also, one of the things that we recommended them to do was copy your files into blob storage. So it's easier, it's faster to restore rather than actually copying from over the internet and restoring it. So along with this, being on the customer success team, and also we work very closely with the product team on our end, we've been listening to a lot of the feedback from our customers and sharing them with our product team. As a result, we also enabled a configuration called storage compression in the back end. The basic idea of storage compression is actually to compress chunks of data that's getting written to storage. This essentially brings down the size to at least 50% of the original size. So in this case, in the case of Staples, they were at about like 20 to 21 hours of, that's how much the restoration took for them for their workload. Along with all the backup and restore switches, as well as the storage compression that was enabled in the Postgres service, we were able to bring them down to less than 6 hours, which is the ideal time frame for them. Another learning also for us from working with this customer and also enabling this was the Azure Database Migration Service. It is a first-party solution that Microsoft offers or enables migrations from a source to a target. We enabled Azure Postgres as well as Azure MySQL as target in that service. It's out there in today, so please go ahead and try and use it. So now that we have migrated a customer from wherever they are to Azure, what now?
Thanks, Arini. Now you wonder, like we are in Azure, what does Microsoft does with the Azure infrastructure? What do we do with various things which we deploy in our infrastructure? To call out one thing, like Microsoft is an industry leader in terms of compliance, security, and privacy in our infrastructure. This entails that we have things running which are compliant, which are patched, and we have a regular update going on. One thing we want to do that, any regular update we do, we want to make sure the impact to you, impact to customer is minimal. We start with notification. Whenever any deployment happens in production, we want to communicate to you so that you can work with your customer and make sure you manage the deployment coming in, customers are aware of it. And at the same time, you can set up operational processes in your workflow to manage what Microsoft will do on our behalf. Other than that, we also do timely updates to our infrastructure. We have OS patches, security updates, software evolution. We want to make sure all of them go in a regular cadence in our infrastructure, and you, customer, can benefit from it. Instead of doing piecemeal deployment, we do one security update, one OS update, infra update, application upgrade. We do batch deployment, essentially all of them once in a month, so that the impact to you and customer is minimal. One of the key things which we care about is the availability SLA, which we guarantee to you from Microsoft. And when we guarantee, we make sure that is a key KPI, which we measure internally and iterate over it to make it better week over week, month over month. Other than deployment, we also strictly adhere to Microsoft's safe deployment guidelines. What do? We have presence worldwide. And we make sure we progressively do a deployment so that if we identify any regression in our system, we have the ability to minimize the impact to our customer. And that happens religiously for each and every deployment. So this is what we do as part of our deployment infrastructure, as part of our code rollout. Now you may wonder, that's Microsoft, that's something they do. What we can do as a customer to optimize our workload running in Azure. Here comes customization. You can customize the application. Every customization always comes up with some trade-off between performance, ease of troubleshooting, debugging. So what we want to do now, walk you through a journey of 4 different use cases where we partnered with customers, learned their workload, and helped them optimize it. So let's take a scenario 1. We have TCS, Tata Consulting Services. They are running their DevOps infrastructure on Azure PostgreSQL. And as you know, DevOps infrastructure is mostly read-heavy. It means they are querying the database for project management detail, for Kanban board, for you name it, it's mostly read-only workflow. Then customer identified, what if we disable PG stats statement? They disable it, and they gain 60% benefit in the read query. Now, doing that, it was a conscious choice on behalf of customer to trade off performance over ease of debuggability of the system. Alternatively, you may have heard in Ignite, we launched intelligent performance. We'll talk about it in the next couple of minutes, but that's something we are building to help with the overall debuggability of our system. Coming to case number 2, oftentimes you have scenarios like you have to do sort operation, you have to do aggregate operations in databases. If these sorts, aggregate operations are working on a large table, and they are doing a lot of I/O on a file system on a disk, you will have some level of performance impact. So one of our customer, C3 IoT, they changed the default work memory from 4 KB to 1 gig and gain a significant performance benefit. You can do that too, but I want to make sure all of us in this room understand that any changes needs to be experimented, needs to be validated before it goes roll out to production. Because there's always some level of unintended behavior you need to understand before you roll it out. But that's something C3 IoT did, and they gain a significant benefit from it. Oftentimes we ask, this is a database. Can we do database administration? DBA task, common DBA task which we do on-prem, can I do it in cloud? It's a very fair ask. And we had customer Informatica, which is running, they have built their Informatica cloud on a MySQL in their hosted environment. They have a lot of legacy applications. And all of these applications are old applications, so when they migrated to cloud, they wanted to make sure the configuration which they did on-prem is applicable in cloud. So they had all the legacy application required for them to set the time zone as East US, and they were able to do the same thing in our Azure PostgreSQL service and essentially get the same benefit. This is what Informatica did, and it's significant benefit from them. Other than just the application, like database level customization, customer can also optimize the application for the cloud. Because your application is running cloud, what all you can do to optimize the application. So I have a case study from Sivantos, which is a hearing aid company, industry leader. They build a telecare system. So essentially, you have folks who are wearing the hearing aid devices, and they want to tune their devices, either offline or working with a professional. And they wanted significant performance benefit. They did it while optimizing the application. And let me tell you what all they did so that we can learn from it. Essentially, in any databases, one of the key things is a smart and practical query usage pattern. What do I mean by that? how do I minimize access to an I/O read-write, So what customer did, they said, I will only fetch the data what is needed. If I have a select query, I'll constrain it to what data I need. I'll have appropriate filters to make sure data, what I'm getting on the client side is the reduced set of data. Then they also implemented the ID range in their application instead of relying on database to fetch a new ID each and every time their services are running. Third thing they did was essentially fetching the data and then caching it. Imagine you have a lot of localized strings. Do you need to do a lookup each and every time? Can you build an application-level cache which minimizes the I/O lookup on the database? That's what Savantos did. And the last they did was around consolidating the queries. If you have a lot of singleton select statements, and they're happening quite often, do you have a use case? Maybe. If not, can we move into a model where we have joins, queries are structured a little bit more better? That's what Savantos did to gain significant benefit. Other than these customers, I want to share a few other things which we can do to optimize our application running on top of Postgres database. We can also reinforce our connection resiliency. What does that mean? Can we use connection pooling? Yes. Can we use application retries if the connection is not successful? Essentially building more connection resiliency in the application side. In January of this year, we launched Azure Accelerated Networking. We should use that if we have high throughput, low latency application. Other than that, we can scale out read with read replicas. In Ignite conference, we launched read replica public preview for MySQL, and we are planning to deliver a similar capability in PostgreSQL in coming months. These are the things we did and customer did help to gain insight into usage of Postgres database. I want to bring now JY and Dave from Adobe to talk about their journey on our platform. Dave.
Sure, thanks, Prabhat. Dave, it's a pleasure to have you on stage with us today.
Thank you. It's good to be here.
So you're working for Adobe.
Yes.
So Adobe is one of the marquee customers for Microsoft on Azure PostgreSQL. Can you please tell us what is it that Adobe is using Azure PostgreSQL for?
Absolutely. Let me give you a little context.
Sure.
Right, kind of going into that. So if you go back 2 years ago at Ignite, we had the CEOs of our two companies, Microsoft and Adobe, announced a strategic partnership. And that partnership was targeted around building and creating and delivering better digital experiences for our combined customers. That involved, on the Adobe side, taking solutions like Adobe's Creative Cloud. You're familiar with Premiere, Photoshop, Lightroom, all those kinds of things, and moving those to being hosted on Azure. Also taking solutions in Adobe's Experience Cloud. That's where solutions like Adobe Experience Manager, Adobe Campaign, those kinds of solutions also were part of that, and we're now hosting those on Azure. And most of those solutions have some sort of database need or requirement. And so we have a lot of solutions that are actually using MySQL and Postgres. We're not really a SQL shop, so it's mostly about the MySQL and Postgres. And a couple of those solutions had some pretty challenging database constraint requirements. The one that really we kind of recognized early on, and then I'm looking at Prabhat because we've been working together for how long? Like March of 2017, something like that. So knowing that these challenges were coming to the table, and they're challenges that are difficult for us, whether it's on-prem, any other cloud. It's something we knew going into it. We were going to need to do some work to make sure that it was ready. So Adobe Campaign, what is that solution? What makes the challenge from a database standpoint? So Adobe Campaign is Adobe's platform for designing and visually orchestrating and then executing campaigns. So it sounds like a marketing statement. So what does that mean? So in practice, that means, let's say you're a fast food company in Chicago. and you want to increase your sales by targeting the, say, 18 to 24 demographic. You know, people at school or people at work, you know, you want to get them in, say, for lunch. And so you decide, okay, we're going to, you know, let's offer them free fries, right? And so you want to send that message to them right at the time that they're getting hungry, right? So you go in and you're defining a campaign. You can define a number of attributes around what you want to communicate to them, and they're context-driven. They may be unique with data information about that person that you know. Oh, you've been to this location, you know, a number of times in the last few months. Free fries, anytime between 11 and 1 today, right? And they want to get that message out in a very short period of time to millions of people, and then they want to track live in real time the response, delivered, clicked on, right, or accepted, those kinds of things. So they're coming back at a very rapid rate, right? So we deal with updates of, say, 300 transactions per second, and at the same time we'll have analytic-based queries, some deep queries. In some cases, you're dealing with queries that may go across 100 million profiles and up to a billion events that you're tracking, you know, for these campaigns. And so they can be fairly intensive queries, and some of those may have to be on unindexed columns. So this combination of OLTP and OLAP create a little bit of a challenge. We kind of knew that going into it. So those are some of the key attributes or requirements that we were trying to fulfill.
Okay, that looks a very impressive workload. So how did Adobe and Microsoft work together on that, and what is it that Adobe got out of it?
We started working together early on, like I said, March, long before it was even in private preview. And in the early phases, we were focused on kind of functionality, does it have there? And then later into the year, we started focusing on some of the performance once that started to get optimized. And over time, we saw about a 30% increase in writes. That's just things that we're taking care of as you optimize the platform that helped. And then we also noticed a number of things. We got some good feedback. So there's things on the application side as well that we did to kind of optimize for Azure. We noticed, for example, in other platforms, we have constraints where we run into challenges of getting not enough bandwidth, say, between the compute node that the database runs on and the storage. In Azure, the constraint was we had plenty of IOPS, bandwidth's good, but we noticed latency, and so we needed to optimize around that latency between the compute and the storage. And so we did a fair amount of testing early on to optimize that. So the outcome was, in some cases, we've got like a 17x improvement when we were optimizing, say, our toast tables, because we have a lot of fields that are larger than 8K, and so that page size is the limit for storage in Postgres, and so we had to use toast tables. But we changed that setting based on some recommendations, and we got a 17x improvement in things that were involving toast tables.
What about the DBA experience?
The DBA experience, those are examples, some of the things we started focusing on early on. So let's say, for example, in the area of logging. So with logging, we needed to be able to, on the fly, turn on higher levels of logging to do debug, and then on the fly, reduce that back to the lower levels. We also needed to be able to do things like create custom log retention periods. We need to keep in mind, this is a customer managed service, so we can stamp out hundreds of these. You've got a few DBAs managing things for many customers. So we have to have a really good administrative or management experience in order to maintain this and continue to provide a good experience for our customers with a few number of people. So we also, things like server parameters, so workmem was critical for us.
So that's great, and those numbers are impressive. And so you mentioned a bit about it, but could you tell us in more details about the how? How did you guys reach out those awesome results, like the 30x, 30%? Were there any optimization or changes in the application that you had to take, or was there any particular customization of the assets that you run in Azure, or even was there any improvement in our service that we made?
Yeah, so let's break those down into two categories. So what did we have to change on our application side, on the Adobe side? And then what were things that we changed, either were changed by Microsoft or options that you gave us to be able to tune on the database side? So some of them were kind of no-brainer ones. As we went through it, we found a couple of scenarios where we could use unlogged tables where we weren't before. And that in particular was helpful on an Azure PostgreSQL side due to that latency. So anywhere we could kind of optimize around that, we did. Another big one was, like I mentioned, toast tables. Right? We moved to using main as the configuration option for toast tables, which really, it just says, hey, encrypt, do everything you can to keep it in memory before moving to disk. And then we moved to an 8K size from the default of 2K, and that allowed more things to stay in memory. And for our particular workload, that was the optimization. So tune for it. One solution's configuration is going to be very different from another solution. Just depends upon your workload. So we tried a few different things and found that had a significant impact on our performance improvement there. Okay. So another big one, again, optimized around that latency, is when you have all those events coming back in a very rapid fashion for a campaign, and you're trying to ingest those, hundreds and millions of those coming in a very short period of time, we found that by batching them up a little bit more and having larger transactions, fewer of those, significantly increased. Our performance increased about 10x in terms of updates to the database when we had larger, fewer transactions. Again, optimizing around that latency. It minimized some of the lock contention as well that were a result of that latency. So those are some of the key parts. There's also little experiential things like maintenance. So there's maintenance. That's what we love. We're happy to be out of taking care of doing the security updates and the OS updates and the database minor version updates, that kind of stuff. Happy to be out of that. But you still have to do that once in a while. And there's, within the architecture for Azure PostgreSQL, you'll spin up a new node for us, and then you will redirect us over to that new node. That process takes between 30 seconds and a minute to execute. And we see those about once a month today. It's kind of the current life cycle. If you can have your application handle 30 seconds to a minute from a connection retry standpoint, then all that becomes transparent. Now, scaling up, which is also something that we do because our customers keep growing, and so we need to scale up. It's the exact same process for scaling up as it is for maintenance. So if you can handle those connection retries up to a minute, it really makes that transparent and smooth, and then we don't have to manage that as a managed maintenance scenario with our customers as well. So that was a significant one for us. Another thing was we missed this going in, and that is in Azure when you're communicating, say through a load balancer with a public IP to a database service like Azure Postgres, there is a timeout, TCP timeout. By default, that's 4 minutes. You can up it to 30 minutes. We have queries that run longer than 30 minutes. So let's say, for example, I finished a campaign and somebody's running some analytical queries. If that query is running for more than 30 minutes, we ran into scenarios where we timed out connections. And so setting on the client library, setting the TCP keep alives so that they kept the connection alive before that timeout. That was also an important learning point for us. It's a kind of a gotcha thing. We don't experience that on-prem or some other places, so knowing that ahead of time is helpful. Those are some of the key ones on kind of our side. On the other side, so really when we're trying to deal with storage performance, right? That typically database, that's where you spend a lot of time focusing. And with Azure PostgreSQL, you're scaling bandwidth and IOPS along with capacity. So we might have a smaller customer that may only need so much capacity, but they need a certain amount of IOPS and bandwidth. So one of the lessons learned there was scale your storage. So right now it maxes out in terms of IOPS and bandwidth at about 2 terabytes. And that's really in the range of the database size that we use. And so we went ahead and bumped a lot of those up to 2 terabytes just to optimize the performance in addition to capacity. We already mentioned some of the things. In fact, I was thinking as you're as you're walking through the other customer use cases, I'm like, okay, setting pgstat statements to none. That was what we found together, right? The TCP keep alives, kind of picking up on that. We found that setting the transaction sizes, These are all things that we kind of worked on and discovered together early on. Accelerated networking to optimize the performance between the client and the database. All these were things that we kind of picked up together, and I think we were the first ones to kind of notice that because we started really early on kind of figuring out, okay, what do we need to know? And it's great to see that other customers are gaining benefits from that learning. I also noticed there's some of the pages online. You can go and look at PostgreSQL performance recommendations, and a lot of that stuff that we learned is also in there. Another thing from a security standpoint for Adobe, having a connection terminate at the database server level just it's a non-starter for us from a security standpoint, at least from our security team. So the VNet service endpoints where we can apply that security at the network level, that works great for us. So that was certainly one of the things that we adopted very early on. Those are some of the highlights. I think there was monitoring things, that we dealt with as well. Like one of the key things is if your storage gets up to 95% of utilization, it flips to read-only to protect you from corrupting your database, which thank you very much for that. But got to make sure we're getting those alerts. So enabling those alerts is an important part of kind of our process.
Great, great. I'm very glad that Adobe successfully implemented and built this digital marketing solution at scale on Azure PostgreSQL. Thanks, Adobe, for your business. Thank you, Dave, for your collaboration and joining us on stage today.
Thank you, Prabhat. Lots of hours spent. Thank you.
So let's take a minute and put things in perspective. We've heard about customer stories around how customers migrated to Azure PostgreSQL and Azure MySQL. We heard about other customers about how they tuned and optimized their workloads to get the best experience from our services, right? For each of those stories, we saw hints and recommendations that you will take home and implement. So what's next? As we listen to the customer feedback and as we work with you, our customers, we are consistently reassessing and adjusting our roadmap so that we ensure we deliver what you need to get an awesome experience with our services. And I'd like to highlight a few of the investments that we are making that come directly from the engagement that we are having with you, our customers. The first that comes to mind, actually, is about this extension of PostgreSQL. What's the name of it? PLV8. You guys have been very, very vocal about it, right? We listened and we delivered. So you guys can go and use it today. That's one of the many extensions that we support today. But that one in particular, we listen to your strong feedback. From a troubleshooting standpoint, we are starting on October 1st the preview of intelligent performance in Azure PostgreSQL. Intelligent performance is a feature built in Azure PostgreSQL that allows you ultimately to accelerate some of your queries. How does it work? In a nutshell, intelligent performance allows you to track how the database engine executes the queries and track what kind of weight it uses. From that, in the Azure portal, you can visualize what queries are slow and what does the service recommend to you to go do to make these queries faster. So please go ahead and use it. We are very eager to get your feedback on that. You should get a very nice experience about that. About tuning, across our services, we consistently increase and enable more and more server parameters so that you can tune the behavior of the database engines to the specificities of your workloads. Grow. You also told us that you would like to use bigger configurations. Today, we support up to 32 vCores and 4 terabytes of storage. And we listen. We continuously augment those numbers, more vCores, more storage options, so that our services can support the growth of your business. So Today, we talked about a lot of things, right? I guess that you may not have enough time to take all the notes you wanted, but don't worry. Please download the slides and get the details, in particular in the notes section. You'll get all the details about what we discussed today. That being said, there are a few resources that I would like to call out because they are going to be very useful to you, I believe. First, I would like to encourage you to continue to share feedback to us through user voice. There, you can share feedback, requests, capabilities, features, but more importantly, you can vote on each other's ideas. Those votes are a critical piece of data for us as we prioritize and define our roadmap. So please go use those user voice forums. You have one for each of the database engines that we support in Azure from an open source database standpoint. Please go continue to do that. Also, engage with us, engage with engineering. Send us emails about your experiences, perceptions, ideas, right? Questions. We'll be glad to interact with you. Watch and read. This week at Ignite, we have delivered several sessions. Actually, there is another one right after this one, completely across the building, W340, I think. So please attend those sessions, learn more about what we do in that space, and you can watch the recording online as well. In addition, there is a bunch of useful resources online about our performance characteristics, the data migration guide, and case studies as well. Right? Migrate. Embrace the Azure platform. Microsoft will support you in those migrations. Please reach out to Microsoft through the Fast Track program. That concludes our session. I'd like to thank you all for attending and joining us today. While you are evaluating the session, I would like to open the floor to questions. Note that if we don't have enough time to answer them all, please reach out to us by email, or better, please join in and meet with us on the booth, the Postgres and MySQL booth in the Data and AI section of the exhibition hall. Thank you. Question?
What are the larger sizes?
So the question is, when will the larger size be available?
So larger size depends, like we are talking about a storage and virtual core. So both. So vCore, right now we support 32 vCore. By end of November timeframe, we should have 30 vCore memory optimized and 64 vCore general purpose.
Yeah. So the question is whether we're going to support synchronous replication as opposed to asynchronous replication that we announced at Ignite today.
We just launched the read replica for MySQL as a public preview. We want to hear a feedback from all of you, and those are one of those feedback. And then based on our product planning, we'll figure out a roadmap to deliver. Because this is the early iteration of async read replica. We want to learn and then iterate on it.
Any other question? We have about 6 minutes left, so we can take the time to take any other question or discuss any feedback or experience you have if you have been using our services already. No other question? If you want to come to the booth, we can show you how to use it, how to get started. That's super easy to get started. A few clicks in the Azure portal, and we can get you started.
Thank you for coming.
Thank you, guys.
Thanks, everyone.
Thanks for your time. I enjoy the end of Ignite. Thank you. Bye-bye.